So today I'm going to take you to a different route where we are going to look at a brief terminologies and in data science and statistics and also mathematics. And like I said, do not be scared if you don't have those background. Always just know that it is just for you to understand. It's better you understand something than you walked blindly in that area. So that's the purpose of making sure you have the grasp of the theoretical knowledge. But the class is going to be more of practicals. Okay, so most of the skills you're going to be learning are going to be practical skills. So uh, don't be scared. I hope you can all see my screen. Can you see my screen?
Yes, sir.
You can see my screen, right?
Yes.
Okay, okay,
I don't know for others, but you can see they
okay.
are not speaking up. Hey, Justina, are you there?
Okay. You guys can see the screen, right? Can somebody
You
on?
need to unmute. You
Can,
need to unmute yourself if you want to talk.
We can see it. We can
okay,
see it.
very good, very good. Okay, so today I'm going to take a look at a different view. Just a brief terminologies I'm going to introduce you to, and then quickly I'll see what happens when we have time. So, like we have already established in our previous studies about what data science is. Like I said, that in the previous studies, I told you guys that data science is a combination of several fields, the combination of mathematics and statistics, and also some sort of computer science skills like hacking skills and data engineering. And then we also have the domain knowledge side of it. So it means it's not just enough to have the computer science and the statistics, but also for you to translate this knowledge into specific areas. Areas such as business, economics, healthcare, you know, engineering, and so many other areas. So when you are learning data science in this class, I want you to begin to reflect how would you be able to use these skills that you are going to acquire to solve problems in your areas of interest. Now, at the intersection of this data science here, you could see where data science lies. You could see that we have the hacking skills, we have the mathematics and statistics, the traditional research approach, that there is also the danger zone, that where you could find other knowledge that are not relevant to you. There are skills you could learn, for example, like hacking skills that can be translated in a negative way. I don't know if you, of course, you're in Nigeria, you must have heard of hackers and all those Yahoo Plus stuff and the rest. So there are knowledge that you get that you don't need them because they are not the right knowledge for you. But data science is the intersection of all those things. So we apply different techniques and processes to be able to carry out wonderful things. Now, it has been established at a world magazine that data science is the sexiest job of the 21st century. So the question someone will be asking, why do they say it was the sexiest? I don't think now it is, but probably in 2015 down to 2018 it was the sexiest job. But now I think other jobs are taking over from data science, such as data engineering and also large language models. You know, although these are all part of data science, but we are having experts that are beginning to come up in those areas that are now in much high demand. So data science is still not, but it's one of the hottest job. It is important to um, people because it uses the knowledge of mathematics and also engineering and other domain knowledge to be able to harness data from those areas. Okay, so data science is all about combining those fields. machine learning, data analysis, and domain knowledge to be able to answer questions. Remember in our last class, I talked about you are always trying to answer questions. There are research questions you want to answer. So, in order for you to answer a research question, there must be a hypothesis. In a given problem, what kind of data do you need to solve this problem? So that's when you now looked at. So remember last class I told you that the moment you have data, you don't just jump into the data and start analyzing the data. No, you have to be systematic. You have to be scientific. Okay. So what you need is to ask question. What are you trying to achieve with this data? So you have to understand the data, then you carry out data-driven approaches. So it means that you solve these problems using the data itself. Remember in traditional research,
Hello?
like statistics, in traditional statistics, we usually come from the method to the data. But in the case of data science, we come from the data to the method. Are we on the same page?
Yes, sir.
Good. So here you come from the data to the problem. So whenever you have the data, you use the data to answer the question. But in mathematics, in statistics, you usually developed a methodology before you now look for a data that follow. That's why you hear statistics talk about normal distribution. Normal, and you begin to, oh, what is this normal distribution? Because we usually have to make assumptions before we can be able to guide our research. But in data science, on the other hand, you have questions, you look for data, you answer the question with the data. Okay? So the heart of data science is always asking questions. Always be curious about the world. What can we learn from this data? What actions can we take once we find whatsoever we are looking for? So whenever you have the data, you begin to beat the data. You begin to, when we say beat the data, it's just like when I was growing up as a child and something get missing, they will put you and begin to punish you and say, who stole this? Who stole this? And then you say, oh, I did. And then the other person will say, I did. Now that process where you beat, so in this case, you are not beating humans, but data. You try to crunch the data until you get the right questions that you are looking for. Okay? So that approach of beating the data, crunching it to get insight, it helps you to be able to learn something. And mostly what you are learning is you are going to be learning patterns. What patterns am I seeing in this data? When I'm observing a demographic data on in area of health, okay, I'll be speaking more of health because that's where I apply my data science skills. So let's say I'm looking at diabetic patients and I discover that their demographic data, there are more of women or men. Then the next question is, why are there more men having this particular illness than women? So we begin to go down to narrow. So the data help us to spot patterns. And when we spot patterns, we now begin to further investigate why this. Okay? Now, there are different types of data. Data is not always clean. Data is not always clean, and there are different type of data. There is the structured data, and then there is also sorry. So there is a structured data, and then there is also sorry, I wanted to enlarge this a bit for you. Okay, sorry. Okay. So there is a structured data, and then there is the unstructured data. Okay. I wanted to make it bold a bit for you, but I think it's fine. So the structured data are those data that has a well organized form. A good example are data that are stored in relational database, spreadsheet, and table. Um, so when I talk about structured data, let me show you guys an example of what we say from Excel, for example. So those data are always organized. The structured data are already organized. So they are not really data that are so abstract. They in other words, tabular data are structured data. Okay, tabular data are structured data. Um, let me show you guys an example. It's just an example. So I think it's fine. I could show you this. Okay. As it's loading, I will continue when it's finished loading. So there is also the unstructured data. So the unstructured data are usually data that are not organized. The unstructured data are in form of text, they are in form of images, they are in form of audio, and they are stored in different formats. So those ones, they are not organized. You have to be the one to organize them. Then there is also what we call the quantitative data set. There's also what we call the quantitative data set. So when I was talking of structured data, this is an example of a structured data. You can see there is the patient ID, there are slopes, and there are first date of transplant, so many biomarkers, but you could see they are organized already. The data is organized already. So that's an example of what we call a structured data. Even though it may be looking weird, but it's already in organized form. Okay? Then, when we now talk about unstructured data, those data are not organized. They can be in form of images, like X-ray images. Okay,
Yes,
they can
no.
also be in form of audio. So have it in mind. Those data are not organized. Then when we talk about numeric data set, on the other hand, okay, I think you guys are still with me. Sorry. So when we talk about numeric data, quantitative data set, they are numeric data set. Okay, quantitative data set and numeric data set. A good example is height, weight, uh, age. They are numeric. Now, this kind of data can be in form of decimals, like the data I just showed you. You could see there are some that are in form of decimal, some are in form of a whole number. So these are example of numeric data. When you are taking the height of someone, you could say this person is 5 feet, 5.2 feet, 5.3 meters. You put it in decimal and all that. So the example, those are numerical data. Then there is a categorical data set. So when a data set is said to be categorical, these are those data that have label, and we divide them into groups. So now, when I come, for example, and say this is a boy, this is a girl, I put them in categories. Okay, so they cannot be in form of numbers because they are categories. So I could say this. I can even put for example race. I could consider different race and say these ones these ones are Africans, these ones are Europeans. You could put them in different groups. So you could also put profession. So a good example of categorical is when you looked at the questionnaire that I showed you guys earlier on. You could see like the profession of everyone here. These are categorical data set. Okay, these are categorical data set because you're trying to look at the categories of everyone that are attending this class. You want to see who are the mathematicians, who are the computer scientists, etc. Okay, so I think some of you can mute. Some of you can mute so that the noise doesn't affect the background. You can mute it. Then whenever you want to talk, you can unmute it. Okay. Whenever you want to talk, you can raise your hand and then you unmute it. Okay, thank you. So, academic background is also a categorical, because you try to know, are they in high school, are they in bachelor, are they in masters. So when you put people in categories, or you put things in categories, those are examples of categorical data. Then categorical data can also be in form of ranking. So when we are ranking, we could say that's an example of an ordinal category, because they are following some sort of orders. And then there are that category that you don't need to rank them. You don't need to. You just leave them. I don't know if you have used SPSS before. You will see that in SPSS there are some sort of dialog box that you could drag to see, is it ordinal, is it binary, is it, you see that option there. So the ordinal data set are those data sets that are in orderly form. For example, the ranking of military. You have a private, a sergeant, a private, corporal, sergeant, and all that. They are ranked in a hierarchical order. Okay, so okay, I think John is trying to join. Okay, yeah, yes. Okay, sorry, let's okay. I think some people want to join. Admit all. Yeah. Okay. Okay. Thank you. I think he has been admitted. So there are so many categories. Now, another thing I want you to know is that there is a data explosion, like we established in our last classes. There is a data explosion where we call the big data. And the big data have expanded beyond the 3V. We now have like 5Vs, the value and veracity and all that in the data set. So it's not just 3V, we now have up to 5Vs. So the big data, as a result of, we now have the computational resource, and then platforms also beginning to come up. So that computational resource help us to be able to manage things like parallel computing, and also for us to be able to store these data that are being produced. For example, I don't know if you have heard of AWS, and even Google. They produce that, they give us that platforms where we could store these resources in form of what we call hybrid computing. And for some of you in the future that are likely going to be taking courses on big data, you will get to come across these platforms and what gave birth to some of these cloud computing platforms and how they evolve in the course of time. So you will get to see we have private cloud, we have public cloud, we have hybrid cloud. So those cloud computing provide us with the resource to be able to manage this data in a large scale. So you could imagine Facebook. In the last class, I showed you guys the number of data that is produced on Facebook every day. YouTube, Instagram, and all these platforms, they produce chunk of data every day. So if we don't have the platform to manage them, we cannot be able to do them. And then another thing we talk about is what are the characteristics of this big data. You will know that the data is big from the volume of the data. It's very large. You cannot be able to store it on a personal PC computer. Another thing is the velocity at which this data is coming in from. It's always going to be streaming in very fast. I don't know if you are going to be following the US election tomorrow, but if you are following the US election, you could imagine when election results, and again, that's not like the INEC stuff in Nigeria. I don't think INEC is yet to get there. So you will see the election results coming in from different parts of US, Arizona, Washington DC, Chicago. It will be streaming in, and as it's streaming in, they are showing you the tabulation of the result. So those data are very large. You cannot manage it on your personal computer. So that's what the big data is all about. Then like I said, the memory, you cannot fit it on a personal PC. Okay. Now, sorry. Can this the person mute because of the noise? Can you mute it?
Okay.
Thank you. So we also talk about data sources. Remember, we have established that there are different kinds of data there. And again, sorry, in this material, I could see they didn't talk about the semi-structured data. There is what we call the semi-structured data. The semi-structured data is different from the unstructured and the structured data. And a good example of the semi-structured data is this XML files. They are example of semi-structured data. Web files, they are also example of semi-structured data. Those data are not completely not having structure, but yet they are not completely structured. So they are in between the structure and the semi-structure. Then we have different data sources or formats where this data exists. There is the tabular files where you could find them in CSV format, SLS format, etc. Then the semi-structure, like I said, you could find it in form of XML files. Then there is also the SQL. And SQL is a language on itself. It's a programming language on itself. It is not just a programming language, it's a language of database. So when you are working with database, you're likely going to be using MySQL, NoSQL queries and all that. Now, it helps you to cut, to join, to merge, you know, so it's more like how you play around with Excel, but in this case you are playing with sheets of Excel. So it's like I could take one sheet, I could merge it with another sheet, and then I could be able to do my computation from there. So SQL is the language of database that you need. So these data sources could be in the format of these SQLs, could be in those databases. There is also the JSON files. Most likely when you are working with web files. There is also the HTML files. And it's not here, but it's also something that you should keep in mind. There are protocol buffers, so it could be in several formats. Then in images, for example, we have the PNG, the JPEG, the TIFF, so many formats, SVG. So there will be so many kind of formats that images could exist, and then so the image can be in high resolution, low resolution, RAGB, AGB or something. When we get to those side in deep neural networks, we'll talk about how you could be able to work on these high resolution images. Then we have different data sources. It could come from even yourself. Now we are talking about this class. We're practically using data. We're producing data. So every click you make on your computer, on your phone, it produces data. When you go on your Facebook, when you scroll, you are producing data. So that is what we call the carbon footprint. So you anytime you make a click, you produce a data. Anytime you produce a data. So in the digital world, don't think that these things are no. It is just like you're translating the physical world in a virtual space. So because of that, anything you do, you produce data. Remember, as in the physical world, you take in oxygen and you breathe out carbon dioxide, isn't it? So that is how it is in the virtual world. Every click, you produce a data. Okay? So have it in mind. So data can come from companies, it could be proprietary data, it could be APIs, it could even come from government, it could be academic data, it could also come from web scraping and crawling. And last week I also talked about that the fact that you could see data does not give you the guarantee to just go and pick the data. That's where we talk about ethical and privacy concern. So you have to be mindful of that. You don't just go about picking data and all that. You get yourself into trouble. So before you use the data, you must know where the source of that data is coming from, who owns it, and what are the licensing for sharing. You don't just go about sharing sensitive information of people. That's why when you give out survey, for example, you do not record the names of the people. You will encrypt them. You decrypt, you encrypt. So when you encrypt, in this case, you would change their names to numbers. You can say patient number 123AB, patient number this, so that you don't attach their identity. For sensitive field like healthcare, you don't go about sharing sensitive information so that you don't make those people to feel like I stigmatized. I gave them example last week about in the 80s and the 90s how people do not want to share cup with somebody that has HIV, for example. There was high discrimination. So you could imagine if you were in that era and you go about talking, you are doing a research that has to involve HIV/AIDS patient, and then somebody sees it, this person has HIV, oh, this person has HIV. So you have to be very careful when you are working with sensitive data, not just in healthcare, but even organizational data. You don't go about sharing data with people, okay? So in data science, there are two classes of problem, even though I am not fully in agreement to some of these things, okay? And I'll tell you why. Now, but popularly, there are two classes of problems we looked at in data science. Is it a classification problem or is it a regression problem? Sorry, I don't know if somebody is trying to join or maybe it's okay. I thought we. Oh, okay. I think I needed to always extend it. Okay. Okay. So I think I was supposed to. Okay, it's fine. I think we can only be permitted to do the class for 1 hour. But notwithstanding, if in case if it goes up, I'll put out a new link and then we could connect again. Let's see how that goes. Okay.
Okay.
Yes. It shouldn't be an issue. Let's see. Okay. So okay, it's fine. It's fine. No problem. Okay. Next week. John, are you guys with me?
Yes, sir.
Okay. Okay. So next week I'm going to switch to another platform that could allow us to have meeting for a long time. I'll use my office team to create the class. I think that could give us that 2 hours without interruption. But no problem if it goes up in the next 15 minutes, I'll create a new link. But next week, I'll transfer it to my office team. I think that could give me as much time I want, so we could be able not to be having breakout. But no problem. Let's see what we do before it goes up and we switch up to another link. So I said that in data science, it could be a classification problem or a regression problem. Now, how do you know if what you are dealing with is a classification problem? Before you'll be able to know, first of all, you have to know what I'm trying to do. Am I trying to make a prediction or am I trying to make an inference? Okay, so if you are going to make a prediction, you are likely going to be dealing with a classification problem. However, if you are likely going to be making an inference, you are likely going to be dealing more with a regression problem. And again, how you're going to know? Now, the thing is, the real world has what we call explanation for why things happen. Okay, so let's see in the case of a flood. Let's say there is a flood. For example, we saw there was a flood in Maiduguri some months or week ago in Nigeria. And when you said what was the cause of the flood, a lot of people agreed there was a dam that got filled up, it busted because they couldn't maintain the dam, and it got busted and flooded the city. So, if you want to know, for example, predicting the the risks of flood. So, when you want to predict it, flood is not something that is occurring every time. It's either there is a flood or there is not going to be a flood. And this flood is not that it's happening frequently. So it means that it's something that happens once in a while. So that is not a regression problem. That is a classification problem. Now, when someone goes to the hospital and the person is diagnosed of a disease, for example, diabetes, now it's either the person have diabetes or he doesn't have diabetes. Now, the next question is, what are the causes of this person's diabetes? Now you begin to look at the health health history record of that person. Is this person having a BMI that is obese? Is this person overweight? Is this person underweight? You begin to look at the health record. What is the age of this person? Is this person a young man? Is it a minor? Is it an old person? You look at that. For example, I finished a research not too long with my master's student, and we were looking out for the cases of about I think about 41,000 acute myocardial infarction patients. We're looking at their data. We wanted to see what sort of pattern. So, sorry, can this person mute? So we don't have noise coming up from the background. So we wanted to see the patterns that were coming up from that data of acute myocardial patients. So we look at a pattern that was coming from the patients that have the disease and those that do not have the disease. So that is a classification problem. So anytime you are trying to look at the chances of something occurring, now a classification problem itself cannot stand when you do not have what you want to predict and what are the predictors. So what are the predictors? The predictors are the causes that are making that particular event to happen. So in the case of the flood that I gave to you guys, you will begin to look at what led to the causes of the flood. One, there was the issue of a dam busting because of lack of maintenance. So the question now you begin to look out for, is it the allocation? Was it that the dam, they could not allocate money from the government to take care of it? So that could be a factor. Another thing is, who are the people that are responsible in keeping this dam safe? That become another factor. So those factors that lead to that event occurring are called predators. Or in other words, in statistics, we call them explanatory variables. Are we together? Are we all on the same page? So,
Yes.
good. So, in the case of the diabetes I told you guys, you could imagine the person, what could lead to the person diabetes could be risk factor. Probably in the family history of that person, their mother or their father or someone in between has the disease or suffered from the disease. So there is high chances that their genetics could pre-expose them to the risk of getting that disease. Another thing could also be diet. What kind of diet is the person feeding on? What are the socio-economic indicators that are causing it? Is it that this person was exposing himself too much to, for example, alcohol, carbonated drinks, and all that? Another thing is lifestyle. You begin to look at, does this person do exercise frequently? Does this person sleep for 5 hours, for example? Does this person, you begin to look at all those things that could have triggered the cause of the illness. Then Another thing in statistics we now begin to do, we try to now control for these things. And I say, okay, why not we control for this and see which of the factors could be statistically significant? And all this buha, and I wouldn't want to bore you much with some of this complication, but I want you to understand that the classification problem must have an explanatory variables and a dependent variable, or the target variable. In computer science we say target variable and predictors. In statistics we call them independent and dependent variable. So there must be a cause and an effect. So in physics you
Yes.
can look at it like the Newton law. In every action there is a reaction. Okay, good. So another thing is the regression problem. So in similar way to the classification problem, the only difference between the regression problem is the fact that in regression problem you do not need to be looking out for an event, but you are looking at a continuous spectrum. For example, you want to look at stock market, for example. You want to look at if in the future this particular stock is going to fall, or in the future it's going to move up. So that is not something that you could be able to capture it for a part. It's a continuous thing. And I don't know if you have followed stuff in cryptocurrency. You will see that it goes up, it comes down, it goes up in a sinusoidal sort of movement. So when you look at that movement, it's some sort of a continuous thing in a real time. So those events that are continuous, for example, you want to predict annual rainfall. Annual rainfall is not something that you could capture them uh, as occurring or not occurring. Rather, you want to measure it if it is high or mid or low, some sort of like that. And this measurement are things that has to be continuous on a spectrum. For example, salary. Eh? Your salary increase, like you know, this you could hear the government will say, no, we are going to pay you 61,500. That 61,500 is a continuous number. Do you understand? So these things are not binary themselves. So it means the dependent variable in a regression problem is not binary. Rather, it is continuous. So when somebody bring a problem for you and say, I want you to do this for me, the first thing you now look out for, what are the predictors? What are the explanatory variables? Then what are the dependent variables that I am trying to analyze? Now, is it going to be a binary case, or is it going to be a regression problem? So identifying them is very crucial, because if you do not identify them, you are likely going to have a problem in making a good analysis. So example here, we talk about GDP of a country, stock price, income. Like I said, I told you guys about salary. All those things are example of a regression problem. Now, you cannot be able to do data science. Are you guys still with me? Sorry. So you
Yes, we agree with you, sir.
okay, thank you. So
Yes, we are in.
okay, so you cannot be able to do data science without having an overview of what probability is. And it's so funny. I remember my undergraduate when there is a course, and I'm sure John know what I'm saying. Even though John was my immediate junior in the university, but he knows what I'm saying. There is a course called Star 111.
Yes.
Please keep quiet. I'm doing something. So there is a course called Star 111, and that Star 111, you will discover that as a fresh undergraduate in mathematics, computer science, and statistics, you are likely going to do that. You know, you come in and they scare you with these axioms of probability, and they begin to tell you how to derive them and all that. And it was, and the man that was taking it was not helping. I think he's late now. He was not helping the matter. He came in and he told us and said, look, when by the time you get to 400 level, I am sure I'll only see not more than 3 or 4 people in this class. And I was like, is this bad? So I went in with that, to the class with this. I was so scared because I was like, what kind of a thing is this? Who brought me to this mathematics stuff? I was so scared. But I get to realize later on that no, probability is all about you trying to understand the possibility of an outcome event happening in the real world. Now, you see, the problem we have in Africa is we could not marry theory to practical. So that makes students not to understand the importance of what they are studying in the classroom. So, probability in this case is that when I have a space of events, when I have a pool of events, I want to be very sure that what I am selecting is the right thing. I remember in secondary school, we used to there is this part of they say probability and all that in WAEC, where they will tell you that there are 5 balls. One is red, one is blue, one is green. What is the probability that I draw without replacement? And all that,
Yeah.
and then we begin to do those things. But when you looked at it in the real world, it's all about choices. Probability wants to help you to make the right choices. And for you to make a right choice, you have to make sure what you are picking is right. So if I know that the chances that I'm going to invest in this business is going to be, and I think, okay, so I think now okay. Okay.